So welcome to Pre-Calculus 30. This is Chapter 8, Section 8.1. We are introducing ourselves to the concept of logarithms here. So we're going to make a quick little review of inverses. Recall that an inverse of a function is obtained by switching the x-coordinates with the corresponding y-coordinates. So if you have a table of values, all you do is simply swap them and you have the inverse once you plot those points. Now, this is also known as a reflection about the line y equals x, which is the oblique line with a slope of 1 that passes through the origin. Complete the table of values below for the function y equals 2 to the power of x. So 2 to the minus 1 is 1/2, 2 to the 0 is 1, 2 to the 1 is 2. Notice we're just multiplying the previous number by 2 every time to obtain the next. Now if we swap these, take all our y values, plug them into the x column, get 1/2, 1, 2, 4, 8. We're going to use these to plot later. 1, 2, 3. Sketch the graph of the function on the Cartesian plane. So that's this first function. We're going to sketch so as quickly as we can here when x is minus 1, y is 1/2. Not very accurate with this thing, but there we go. 0 and 1, 1 and 2, 2 and 4, and 3 and 8. So once you have that, you can go ahead and try to draw your line a little better than I drew mine. Try to make these points more obvious so we can see when they're reflected. Now, when we reflect these points, we're going to reflect them in the oblique line x, or y equals x, which again is this line that passes through the origin and has a slope of 1. So this is what an inverse is. So we are reflecting all these points in that line. So if we just plot these, we'll find out that we've set it up to be a reflection anyway. So if x is 1/2, y is minus 1. So x, we go 1/2 minus 1. Plot our first point there, and you can see it's a reflection of this point there, equidistant from that y equals x line. X is 1, y is 0. That's this point right here. Okay. X is 2, y is 1. It's that point right there. And again, you can just take these points, make them 1, 2.5, 1/2, 1, 2.5. And you should find that they actually line up perfectly with the ones we plotted. 8 and 3, and we happen to be at 8 and 3. Perfect. Now this, go all the way down, never crossing that y-axis. This one would go like that. And we're done. You can read that if you want to. It's in your textbook. For the exponential function y equals c to the power of x, the inverse is x equals c to the power of y. This inverse is also a function and is called a logarithmic function. It is written as, can't find my notes. It is written as log base c of x equals y. Where c is a positive number other than 1. For the warm-up question 1, the exponential function graphed is y equals 2 to the x, and the inverse function is log. Now the base here becomes the base of our log. It's easy to remember that it's the base because it's the lowest physical part of the function. And our exponent goes right here, and then the answer is actually over there. So log base 2 of x equals y. In general, we can say that log base b of n equals e if the following is true, where the base b is the base here, e is the exponent, and n is the answer. Logarithm is really an inverse function of the exponential function. Since our number system is based on powers of 10, logarithms with base 10 are widely used. They're called common logarithms. And when we work with common logarithms, we can just leave out the base 10. So if you just see log 1000, it means the exact same thing as log base 10 of 1000. Now this means what to the 10 to the power of what will give you 1000, and the answer would be 3. So evaluating a logarithm, evaluate the following: log base 7 of 49. So this means 7 to the what power will give you 49. And we can solve this just by inspection. We know that 7 times 7 is 49, so 7 squared, 7 to the power of 2, therefore x equals 2. Now, 6 to what power will give you 1? We know that anything to the power of 0 will give you 1. 6 to the 1 is 6, 6 to the negative 1 is 1/6, and 1 is the multiple of 6 that falls right in between them. So 6 to the 0 will give us 1, and therefore x equals 0, and you're done. Log of 0.001. Now, this doesn't show a base, so we must assume that it's base 10. So 10 to what power will give you 0.001? Now, 0.001 can be written as 1 divided by 1,000. Okay, so 10 to what power will give you 1 divided by 1,000? And 1,000 can be written as 10 to the 3. So 10 to the x is the same as 1 over 10 to the 3. So what is x? Now again, we can take this and we can flip that denominator up to the numerator if we change the sign on the exponent. So 10 to the x is the same as 10 to the minus 3. Therefore, x equals minus 3. And we're done. A little bigger. Okay, so let's move on to the last one. Log base 2 of root 8. Now this is going to involve a change of base like we got used to in the last unit. So 2 to what power will give you the square root of 8? Let's try to write everything as base 2. 2 to the x equals square root of 8 can be written as 2 cubed. Now, since this is a square root, it's 2 to the numerator over denominator. And the radical index here not shown is a 2 because it's a square root. So this can be written as 2 to the 3 halves. 2 to the x equals 2 to the 3 halves. Therefore, x equals 3 halves. And that's it for that one. So here's a your turn. Oh, these got all messed up. This is supposed to be a radical index of 5. And these are just square roots, or not square roots, but fifth root and a square root for this one. So go ahead and give those a try. After you unpause it, the answers will be here waiting for you. So hit pause now. Yeah, right. Welcome back, maybe. Here are the answers, so you can go ahead and double check those. Okay, now some other examples. Determining the value of x. Now x is located in various positions in these 3 examples. Let's inspect the first one. Now we always start with base, to the exponent equals this number. So, for example, number 1, we have 5 to the minus 3 equals x. Now, 5 to the minus 3 is the same as 1 over 5 cubed equals x. 5 cubed is 5 times 5 is 25, times 5 is 125, so 1 over 125 is x, and that's your answer. So let's take a look at the next one. Now, this time, our variable is our base, so we have x to the power of something, and that is written over here. So x to the 2 equals the answer right here, which is 36. X squared equals 36. So what's the value of x? Take the square root of both sides. And normally we would say x equals plus or minus 6, but for a logarithm, it has to be greater than 1. And we wrote that in our notes somewhere back here, where c is a positive number, other than 1, I guess. So it has to be a positive number other than 1, so it can not be a negative. So we discard the negative value and only stick with x equals 6. All right, the third one here. Now again, this is our base. This is going to involve some trickery. This is our base, and this is our exponent. 64 to the 2/3 equals x. So what is 64 to the 2/3? This is going to get tricky. 64 squared. That is what will go under this right here. 64 squared, and we are going to take the cubed root of that thing. Now, really, it doesn't matter what order we do this thing in. So I'm going to take the cubed root first, because I can't do 64 squared in my head, but the cubed root of 64 I can do, because I know that 4 times 4 is 16, multiply it by 4 again, and that will give you 64. So the cubed root of 64 is 4, and we end up with just 4 squared equals x, and therefore x equals 16. Now, it would work just as well if you did it the other way, if you did 64 squared and then somehow found a calculator to do the cubed root of whatever the result was. But that's a lot more difficult, in my opinion, so I would not recommend doing it. Another thing you can do, if you don't recognize 64 right away as the cube of 4, you can try to write this as something else. Say base 2. So 64, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, and a sixth time would give you 64. So 2 to the power of 6 is 64, and then you could square that. Now, 2 to the power of 6 squared would be 2 to the 12, and we are going to take the cubed root of that, which would give you 2 to the 12 over 3. 12 divided by 3 is 4, so this would be 2 to the 4, and 2 to the 4 is 2, 4, 8, 16, and we get the same answer that we got over here. Okay, just a couple different ways to look at it and think about it. So here's another your turn for you to try. So once you unpause it, the answers will be here, and you can double check them. So hit pause now. Welcome back. Here are the answers to the your turns: 1/16, 1/2, and 27. If you got them wrong, go back and try again. See if you can work towards these correct answers. Okay, now the last thing we're going to do in this lesson, state the inverse of f of x equals 3 to the power of x. Now, the inverse is going to be a log, so it will be, if we wanted to rewrite it, it would be x equals 3 to the y, or x equals 3 to the f of x. But we're going to write it in log form. So log, we start off just by writing log. Now base is the big number, the base of the exponent here. So log base 3 of, now the exponent always goes on the other side, so this would be the answer. F of x is x. Okay, so there you go. 3 to the x equals f of x. So this is what it would look like. Sketch the graph of the inverse. Identify the following characteristics of the graph. Now, in order to sketch the graph of the inverse, I am going to start with just some values for the original function y equals 3 to the x. So if x is minus 1, y is 3 to the minus 1, which is 1/3. X is 0, that's 1. If x is 1, that's 3. If x is 2, this is 9. And I think we're just going to stop there for now. So if we're sketching the inverse, we flip all our x and y values. So our y, we get -1, 0, 1, 2. That's enough. X, we get 1/3, 1, 3, 9. Now, quickly make a rough sketch here. Let's go, our x values need to go all the way up to 9, 2, 3, 4, 5, 6, 7, 8, 9. And our y values only need to go up to 2. So I'm going to space them out. 1, 2, 3, -1, 2, 3. And I'll change my pen color. Let's plot these points. So when x is 1/3, y is -1. So 1/3 is right about here, and y is -1. It's right about there. X is 1, y is 0. That's right here. X is 3, 2, 3, and y is 1. Right there. X is 9 and y is 2, so that would be this point right there. And your graph is going to look something like that, except it won't get further away from 0. Sorry, my coordination is just off with this unit. Okay, so let's quickly figure out what these 4 things are: the domain and range. The domain for our logarithmic function, are we allowed to use any value of x? Well, no, we're actually not allowed to use any negative values of x. So the x values are only going to be above 0, because actually we can't even use 0 for x, because this graph will never cross that line. So the domain is x such that x is greater than 0, but otherwise within the real numbers. And y, now you notice this arrow would go down to -infinity. This arrow would eventually keep climbing up to positive infinity, and they would never stop. So y, such that y is an element of the real numbers. It can be absolutely anything. The x-intercept, if it exists, well, yes it does. The x-intercept is when y equals 0, and that's this value right here, x-intercept, done. The y-intercept, if it exists, it doesn't. It doesn't exist. This will never cross the y-axis. Just like with your exponential function, it will never cross the x-axis unless it's been shifted. This one will never cross the y-axis because it's the inverse, so it just flips about that line, and the axes have the opposite function. The equations of any asymptotes, because it will never cross this line, the equation of the asymptote then is going to be the, it's going to be the x equals 0 line. Okay, so this axis, the y-axis, is where you will find the asymptote, x equals 0. All right. I'm going to leave you to do this your turn on your own, and again, after you unpause it, the answers will be here, so hit pause now. And welcome back. Here are the answers for the your turn, so you can pause your video and take a look at this and see how you did. Okay, I will see you in class. Oh, no, we got one more. Sorry. Thought we were done, but we're not. Without using technology, estimate the value of log base 2 14. So we'll rewrite this 2 to the something equals 14. We don't know what it is. Now, in order to estimate this value, I'm going to go with a few other known values. 2 to the 2 is 9. That is so just not true. Thought we were doing 3's there, I guess. I don't know. 2 to the 2 is 4. 2 to the 3 is 8. 2 to the 4 is 16. So 14 is somewhere between 8 and 16. Therefore, x must be somewhere between 3 and 4. 14 is a lot closer to 16 than 8 is. So x must be a lot closer to 4 than 3 is. So I would estimate somewhere around the 3.7 or 3.8 region. And we can see which one actually gets us closer to 14. So go find a graphing calculator. Try 2 to the power of 3.7. 12.996. So that's almost 13 on the nose. Let's see if 2 to the 3.8 gets us closer. 2 to the 3.8, 13.93. That's very close to 14. And since we're only asked to estimate to one decimal place, 3.8 is going to be the closest we can possibly get. Okay, and that's it. And that actually is it this time. That's the end of the lesson. I'll see you in class tomorrow. Oh, there's a your turn for you to do. I guess I better post the answers for you in case you actually want to try it. 3.6. See you tomorrow.